Now in this video, sorry, and continue with what we were doing. Initially, we've been handling mixtures, and I defined a mixture as consisting of two or more substances put together, but the individual components forming the mixture still holds their chemical and physical properties. I did a video on types of mixtures, and we've handled solid liquid mixtures, and we've also done solid liquid mixtures in which under solid liquid mixtures we had two types. We had soluble and insoluble. We had soluble and insoluble solid liquid mixtures. And under soluble solid liquid mixtures, I said that we were having techniques that we could use to separate. An example of a solution that I gave, which was salt solution. And in the previous video, I did crystallization as a technique. Now in this video, I want to handle simple distillation as a technique we can also use here. Now, what I'm going to start with is simple distillation in this video. And I want you to be very attentive. Have a notebook with you and a pen. Now, in simple distillation, we can be interested in both the salt and the water that was used to dissolve the salt to form the salt solution. Remember, when we mixed these two, we formed salt solution. And now, if you want our salt and water at the same time, we can come up with a diagram that is going to demonstrate how this experiment is supposed to be structured and be done in the lab. So I'm going to do a sketch of how a simple distillation diagram looks like. Now, I'm going to start with the round bottomed flask, a round bottomed flask like this, and in that round bottomed flask, I'm going to have a delivery tube, and I'm going to cork it very well. I'm going to cork it very well. Then, after that, I'm going to connect this to a condenser. It's just a tube that is leading all the way down. It's just going all the way down. Now, it's supposed to lead to a collecting vessel down here, which is just another flask. Let me draw it very well. I'm a little bit sketchy. Yeah, it's just going to be, let me put it as a beaker in simple terms. I'm going to have a beaker. Now, this tube is supposed to be connected, this delivery tube is supposed to be connected to a condenser. And it's supposed to be connected to a condenser. And my condenser is going to look like this. Condenser is going to be like this. Then, like this. Sorry, so it will be sketchy. I'm autistically challenged in drawing, but I can try. Now I'm bringing it, sorry, that's very bad. I'm bringing it down like that. Yes, at least that. Then I'm also going to bring this one down like this. Then I bring this one down like this. Yes. Then, because this thing cannot hang, I'm going to put a tripod stand. Then a wire gauge is always needed here. Call it a wire gauge. Then this is the system that we're going to have. Then let me now do. Then inside here, sorry, I'm going to have the salt solution. So this is going to be my salt solution. Sorry. So this is my salt solution. Now this is wire gauge. Wire gauge. Then this is my tripod stand. This is collecting beaker. Just a beaker. Then this is just my delivery tube. Delivery tube. Then this is a condenser. And a condenser always has water in it. It's always having a water system that helps cool the vapor. Now this is always inlet. This is outlet. And I'm going to label that very well for you to know that this is water in, water inlet. Then this is water outlet. The whole system is just a condenser. It's always called Liebig condenser. But you can just call it condenser. There's no big deal. Now this is our volumetric flask or round bottomed flask. You can call it round bottom flask. Yes. Now this is the system that we can have whenever we are discussing simple distillation. So I can even go ahead and give you a heading, a simple distillation system. Now we are supposed to have a source of heat somewhere here. Sorry, I did not mention that. Source of heat, meaning we have to heat it because it is a mixture consisting of salt and water. So what will happen here is that what will happen when water is heated, steam, water will boil, sorry, when water is heated it will boil, then steam will flow through this tube up. Then when they get here, they are still in vapor form. Then this Liebig condenser, or the condenser having cold water, remember we're supposed to have cold water in, warm water out, warm water out, will cool it, the vapor down. And now at the end of the day we'll be having pure water here condensing down. So this is how a simple distillation works. So it separates the system, but at the end of the day what you're supposed to know is that it helps separate a liquid from a solid, a technique that we can use. And also you have also to know that in organizing such a system you have to be very sure that it is really appropriate, meaning you have to know the type of mixture you are dealing with. If it is a soluble liquid mixture, at the end of the day we will remain with salt at the bottom of the beaker. We'll remain with salt. We'll remain with salt at the bottom of the beaker. Yeah, we'll remain with salt at the bottom of the, sorry, not at the bottom, at the bottom of the flask, not at the bottom of the beaker. Inside here, now it is salt that will be remaining because water have evaporated during the heating process, and we will have our water here. So in simple distillation we only use it when we are interested in both the salt salt, which was our solid. Sorry, if we are interested in the salt, which was our solid, and we are also interested in the water, which was our liquid, that was forming soluble solid liquid mixture. So that's what I wanted to say as far as simple distillation is concerned, as a technique that we can also use to separate soluble solid liquid mixtures. Thank you very much and have a wonderful